Okay, good morning, class. Our lesson for today is still under the remainder theorem, but what we will be doing is that we will apply the remainder theorem in solving problems such as this one, solving for the value of k. So, if x cubed plus 2kx squared minus 2x plus 4 is divided by x plus 1, the remainder is 9. What is the value of k? So basically, the procedure of this one is the same as what we're doing in remainder theorem. So we have here this polynomial, and then we have here the binomial x plus 1. Okay, so first step, we will equate this x plus 1 to 0 and solve for x. This will be x plus 1 equals 0. Minus 1 on both sides, cancel that, so x equals -1. Again, using that value of x, we will replace all of the x's by -1. Okay, so that means this will be equal to a -1 raised to 3 plus 2k, okay, -1 square minus 2 times -1 plus 4. And since, according to the problem, if we will evaluate this, the remainder is 9, okay, I'm going to equate this to 9. And if you look at this, we have an equation that has one variable that we need to solve, and that's the value of k. Okay, so let's solve this. -1 raised to 3 means -1 times -1 times -1, that will give us -1. Okay, plus, okay, don't multiply 2k and -1. We have to evaluate -1 square first. So this will be -1 square is -1 times -1, which is equal to +1. You can multiply this, -2 times -1, that is equal to +2. Okay, plus 4 equals 9. Okay, so this is -1. We have +2 here, and then +4. So we can add this 2, that is 6, and then subtract 1, and that will give us 5. So this 3 numbers is equal to 5, and then 1 times 2k will give us 2k, plus 5 equals 9. And then we will subtract 5 on both sides, cancel this, so this will be equal to 2k equals 9 plus a -5, or 9 minus 5 is equal to +4. And finally, we will divide both sides by 2. Okay, so our k is equal to 2. Okay, so that's the value of k when we divide this by x plus 1, given that the remainder is equal to 9. Okay, let me give you another example of applying the remainder theorem in solving problems such as this one. Okay, so this time our polynomial is kx cubed minus 2x squared plus 5x minus 8 divided by x minus 2, and the remainder is 18. Now what's the value of k? So again, our divisor x minus 2, we will equate that to 0 and solve for x. This will be x minus 2 equals 0. So we add 2 on both sides. We cancel this. So x equals +2. And then, again, we will replace all of the x's by the value of x, which is 2. So this will be equal to k, 2 raised to 3, minus 2 times 2 squared, plus 5 times 2 minus 8. Again, since the remainder according to the problem is 18, if you remember the remainder theorem, we'll apply that, this will be equal to 18. Okay, take note that 18, again, is the remainder. Okay? So we have now k here as our remaining variable. We will solve for that. So don't multiply 2 and k. Okay, we have to solve 2 raised to 3 first. So 2 raised to 3 means 2 times 2 times 2, and that will give us 8. So this will be 8k minus, again, don't multiply 2 and 2. You need to solve 2 squared first, so that's 2 times 2, which is equal to 4. And this will be equal to 10 minus 8 equals 18. Okay? Okay, this is equal to 2. 10 minus 8. Okay? Negative 2 times 4 is negative 8. So this will be equal to 8k minus 8 plus 2 equals 18. Okay? Okay, we can solve this. Negative 8 plus 2, and that is equal to negative 6. Okay, we'll bring down 8k equals 18. And then we add 6 on both sides. Okay, it's plus 6 and plus 6. So this will be equal to 8k equals 24. Okay, and finally, since we have 8k equals 24, we will divide both sides by 8. We'll cancel that. So our k is equal to 3. Okay, let me give you one last example about the lesson for today, which is the application of the remainder theorem in solving problems such as this one. Okay, so we have here a polynomial 4x cubed minus 2x squared plus kx minus 5 divided by x plus 1, and when we do that according to the problem, the remainder is negative 25, then what is the value of k? Okay, so again, we will equate excuse me, x plus 1 to 0. So it's x plus 1 equals 0. So subtract 1 on both sides. Okay, we will cancel this. So x equals negative 1. And then the next step is we will replace all of the excess by negative 1. Okay, we have 4 times negative 1 raised to 3 minus 2 times negative 1 squared plus k times negative 1 minus 5 equals, yes, the remainder, which is in this case is negative 25. Okay, and we'll just solve it just like solving a normal equation. Negative 1 raised to 3 is equal to negative 1 times negative 1 is positive 1 times negative 1 is equal to negative 1. So this is equal to 4. Again, don't multiply negative 2 and negative 1. Okay, just like here, don't multiply 4 and negative 1. You have to solve this first. Okay, so this is equal to negative 2 times positive 1, because negative 1 times negative 1 is equal to positive 1. K times negative 1 is negative k. Okay, minus 5 equals negative 25. Okay, now we can multiply this. This is equal to negative 4. We can also multiply that. That is equal to negative 2 minus k minus 5 equals negative 25. Okay, 4, 2, and 5, okay, all of those are negative. So we can add all of them, and that's 4, 2, and 5 is equal to 11. Okay, so that's negative 11 equals negative 25. Okay? And then we will add 11 on both sides. Okay, we will cancel this. So this is negative k equals negative 14. Okay? And then finally, we will divide both sides by negative 1 or multiply both sides by negative 1. So our k is equal to 14.